What's going on, math nerds? Let me know if you can hear me. I am just trying to set everything up on my end. Go ahead and comment anything and let me know that you're here. I am trying to just make sure that my chat is working. For some reason, it's not working on my end, which is kind of frustrating. Otherwise, I'm just going to have to look at everyone's comments on my phone. I'm going to show my camera here. Just trying to see, again, if you're in here, please comment anything. I'm trying to see that my chat works on my end. For some reason, it's just not allowing me to read comments, which is kind of frustrating. So I'm definitely kind of at a disadvantage, but it is what it is. I see a few people on here, but I can't see anyone's names. Let's see. I'm going to try to log on again. And again, if you can comment anything that you're here, please let me know. I'm trying to read everyone's comments on here. But it's kind of unfortunate. Okay, well, we're just going to go ahead and get started. What's up, you math nerds? This is Miguel, a.k.a. the Vegan Math Guy, and I hope you're having a fabulous, fabulous Tuesday, beginning of the week. I've been gone for 2 weeks. I have not been live for 2 weeks, which has been interesting. Took a little break, and now I am ready to continue to get started with you guys. Integration B, we have a bunch of integrals that we're going to do together. If you have suggestions on how we can solve them, go ahead and comment your suggestions. But I have a list of integrals here. I have 1, 2, 3, 4, 5, 6. I only have 7, which is interesting, but I'll definitely look for more later on. But I will love to get everyone's 4, 5, 6. I only have 7, which is interesting, but I'll definitely look for more later on. But I will love to get everyone's input on how to solve specific problems. Gosh, where should we start? Let's start off with something easy, which I think is something that a lot of people should know. I'm going to go ahead and do the integral of root x squared plus 9 dx. Again, if you're on here, please try to comment. I am trying to see that I can actually see everyone's comments on my computer here, and it's kind of annoying that I can't see them on my phone. I see that people are joining. I see that people are liking the video. I'm just going to try to... Oh, this is so frustrating. I am commenting. Comment anything and let me know if you hear. But regardless, again, if you feel like you know or you have suggestions on how to solve this particular integral, please go ahead and let me know. Okay, so we have this integral of root x squared plus 9. Any suggestions on how we can go ahead and solve this? If you guys have any suggestions on that, please let me know. So someone's saying, Yusuf, oh, I can read everyone's comments. Guys, I am so happy. So I think what happened is someone banned my moderator account for some reason. Don't like it. Don't like it. Okay, but everyone's saying Yusuf. I'm going to try Yusuf. Let's see if that works. Okay, I think all the things were delayed. Anyway, so let's go ahead and do Yusuf. Let's see if this works. I don't know if this is a correct method, but it's all about just trying it, right? Okay, so I have u is equal to x squared plus 9. I'm assuming that's what everyone was working. Yeah, so Ravi's saying that Yusuf isn't going to work, and I'm just going to show you why. Because if we go ahead and find our du, which is 2x dx, then we divide the 2x to the other side. We have du over 2x is equal to dx. Check out what's going to happen. We're going to be left somewhat in a weird position because we have the root u times du over 2x. And we can't really do anything about that, because we can try to manipulate our u to solve for x, but it's not going to get us anywhere. So in this case, this is one of those times where you have to use something else. And I can already see in the comments, Ashley said, Tricks up, that's exactly what we are going to do. Ooh, so someone said you have to know that the integral of a square root is a quarter circle. That is actually very true, and I think it's very important to recognize that circle. That is actually very true, and I think it's very important to recognize that this, however, is not the... I don't think this is going to be a quarter circle or even a half circle. But it is important to recognize that type of equation because you can easily be asked to find like the area underneath the curve and all that. But what we're going to go ahead and do is we're going to use trig sub. So everyone started with u sub. It's not going to be u sub. It is going to be a trig substitution. Now, I'm going to draw this out for you, but immediately, because this is x squared plus 9, I know that this is going to be a, was it a arctan, perhaps? We'll see. But let's go ahead and draw it out. So we have our triangle. If we're going to use trig sub, one of our sides is going to be x, the other one's going to be 9. And then now we're going to have this up here as a square root of x squared plus 9. Whoops, on the bottom it's not going to be 9, it's going to be 3. And this is just something that we should definitely, be very familiar with when it comes to creating our triangle here. And now what we're going to do is we're going to go ahead and find a couple things. Okay? So we're going to do that tan of theta, and theta is this angle inside the triangle, is equal to x over 3, meaning that 3 tan theta is equal to x. And now I can go ahead and differentiate this and get 3 secant square theta d theta is equal to dx. Now that's going to help us a lot. Just give me one second. Give me one second. For some reason my computer is just not cooperating today. Guys, just nothing's working today, man. I think my Discord that we have was kind of buffering, kind of unfortunate. So if you are on here, please comment. I'm trying to see everyone's comments. But anyway, let's go ahead and continue with this problem. So we found dx. That's going to be very helpful. And then now what we're going to do is we're going to find that we need to find something that represents the root x squared plus 9. And the way I'm going to do that is I'm going to do that secant of theta is equal to root x squared plus 9 over 3. Because remember, secant is a reciprocal of cosine, so that's hypotenuse over the adjacent. So when I multiply the 3 to the other side, I get 3 secant theta is equal to root x squared plus 9. Now, why did I do that? Because if we look back to our integral, we are going to rewrite this. Whoops, I put a highlighted there. So we're going to rewrite this. The root, the one that I'm kind of circling there in green, is the 3 secant theta. So we're going to write that down. Times, and in our dx is that stuff that I circled in blue. So that's going to be 3 secant squared theta d theta. And then now we're going to go ahead and simplify this. We're going to multiply the 3 and the 3 together and bring it on the outside. So we have 9 root secant cubed theta d theta. And I hate this one. It is easily solvable. However, we are going to have to do... I hate this one. It is easily solvable. However, we are going to have to do some work around it. Solvable. However, we are going to have to do some work around it. Don't know the name for this one. Group delay. Yes, thank you very much. It looks like you already wrote the answer. Thank you. But let's go ahead and continue. As you already know, if you've seen my lives before, you already know that we are going to go ahead and create some space on the blackboard. And this always gets smaller and smaller and smaller. Okay, we have to integrate this secant of cube theta. Who can give me an idea on how to do that? At this point, we've done this so many times that I feel like we should have this almost memorized. We're going to go ahead and rewrite this, and then we're going to use integration by parts. So the way we're going to do this is we're going to do 9 integral of secant squared theta parts. So the way we're going to do this is we're going to do 9 integral of secant squared theta times secant theta. And you're going to see that that's going to prove very helpful. Yeah, someone already said integration by parts. Ryan, thank you. That's exactly what we're going to do. I separated this, so secant squared theta, secant theta, so that I can use integration by parts. So my u is secant theta, so that my du is secant theta, tan theta, d theta. And then my dv is secant squared theta, d theta, so that my v is just tan theta. Okay, so now I'm going to go ahead and rewrite this, and you're going to see that this is going to be very easy to solve once we recognize. Now I'm going to go ahead and rewrite this, and you're going to see that this is going to be very easy to solve once we recognize what to do here. So now I have 9 times the integral, or no, I'm sorry, uv, so secant theta tan theta, minus integral of secant theta tan theta times tan theta d theta. Gosh, and to be honest, I always forget how to integrate that last part. Hold on, I'm just going to rewrite this first. We're going to do it like this. We're going to do secant theta times tan square theta d theta. And now we got to do something about this because we still have that integral there. Now, before we even try to do anything, what I'm going to do is I'm going to rewrite the tan squared, and I'm going to use the Pythagorean identity. And that Pythagorean identity is this one. Don't forget, whoops, that 1 plus tan squared is equal to secant squared theta, meaning that tan squared is going to equal to secant squared theta minus 1. And we're going to use that in a second. Let me go ahead and, as you already know, create some space here on the blackboard. As I'm doing this, I'm curious, where is everyone tuning in from? I am here in a somewhat sunny, cloudy, rainy Seattle weather, but I'm curious where everyone else is tuning in from. No, I do not sound like Ben Shapiro. Fuck that. No way. Okay, let me just go ahead and rewrite this. If I wanted to sound like Ben Shapiro, I would definitely do this. No. London, Scotland, what's up? Texas, Florida, wow, Utah. That's awesome. Okay, as I'm reading these, I'm going to go ahead and rewrite this. I have minus integral of secant theta, and we rewrote the tan, and that's going to be secant squared theta minus 1. We're not going to do much more work here. You're going to see why. Because what I'm going to do is I'm still rewriting this as secant cube theta minus secant theta d theta. Okay. One thing that I'm going to do is I'm going to distribute this 9 into everything. So I have 9 secant theta tan theta minus 9 integral of secant cube theta plus 9 integral of secant theta. And the whole thing is d theta. And don't forget, this whole thing is supposed to equal to 9 integral of secant cube theta d theta. Oh, it's kind of blocking the screen there. It's not fully there. Okay. So here's what I'm going to do. I'm going to do this in 2 steps. I'm going to add the 9 integral of secant cube theta to the other side. And then I'm going to integrate this secant theta that's by itself. This is one that we should all know. Let me go ahead and create some space on the blackboard here. Guys, this is just for the integral of secant theta, and we haven't even finished this problem. But now what we have is 9 secant theta tan theta plus 9 a natural log of absolute value of secant theta plus tan theta. Again, as I mentioned, that was that one integral of secant theta. We should definitely know that one. And that's going to equal to 18 integral of secant cube theta d theta. Y plus 9 secant theta, I had a 9 there on the outside. From the very beginning, that problem had a 9. It was here. I'm circling it in blue. And so I had to distribute that 9 everywhere. And so now I'm going to go ahead and just, now that we have the integral on the right side, I'm going to divide the 18 so that we're left with secant theta tan theta. Actually, all these have 9s. I was going to simplify, but I'll do it in the last step. This whole thing is all over 18. I have my plus c, and that's equal to secant theta cube theta d theta. And that's my integral for secant cube theta. And now the last thing that we had to do, don't forget that in the very beginning, this was an integral that was in terms of x. So we have to go ahead and rewrite every single term in terms of x. So that's something that I'll leave up to you guys. Okay, because I definitely want to touch on more integrals here. I thought this was going to be the easiest one, but it looks like it's the more complicated, I would say. Rafid, yes. Sine of 2x, 2 sine x cosine x. All right, guys, let's go ahead and do the next integral here. And again, please like the video or like the live. Don't forget to follow me on here on TikTok, on Instagram. And of course, you can follow me on the Discord, or you can join my Discord. We have a bunch of people always discussing math problems on there. All right, so let's go ahead and rewrite our problem. Let's go ahead and start off with, this one's easy, I would say. I kind of want to see if there's anyone on here that will fall for this trick. I have secant squared over tan squared x plus 2 tan x plus 1 dx. All right, go ahead and look at that problem. Digest it. Try to understand what to do. If you have any suggestions. Pebbles, I think maybe you just came a little later, but we just talked about a problem with trig sub. I think I might have another one. But those take a good amount of time. But I just did one. Now, I always post these on my YouTube so you can replay it. But that I just did our first problem on trig sub. Looking at this integral, who can tell me what we can do? What should we do in order to solve for this? Any suggestions? Let me know in the comments if you have something that we can do. Oh, my God. Someone from Malaysia, Maryland. I love it. That's awesome. How cool is it that we're all in here together doing integrals and we're from all over the world? Someone said you sub by parts, Steelman. You are crazy. Crazy, but I love it. Okay, you sub. Someone said identity. Check this out. Immediately I see the secant squared on top. Well, that's the derivative of tan. So that's what I'm going to do first. I'm going to make u equal to tan x because du is equal to secant squared x dx. And by default, or if I divide the secant squared to the other side, I get du over secant squared x is equal to dx. Yeah, hoping that we could have seen that. Okay. I still see the chat, but it looks like everything's working on my computer is like messing up today. I have to restart it. Not going to do that during our live though. And then we're going to need some partial fractions. Username 87 is already talking about that. But check this out. Let's go ahead and rewrite this because now we have the integral of secant squared x all over. Remember, our u was tan. So we have u squared plus 2u plus 1 times. And now this is our du over secant squared x that we are substituting in terms of, or we're substituting in for the dx. And as we had said, or we had predicted, those secant squared would cancel out. And now we're left with 1 over u squared plus 2u plus 1 times du. What do we think we can do next? So username and Tony, we're kind of going in the right direction here. Partial fractions. You know what? It kind of looks like it. I would say so. But what does this factor out to? 1 over x plus 1, x plus 1. Let's talk about how we're going to do partial fractions. I'm not even going to, well, I might take some shortcuts, but let's talk about that. So what's going to happen is, I believe Tony said, oh, this is going to become 1 over u plus 1 squared, and that is 100% true. That is correct. Again, if you were to just kind of use your algebra there, think about that. U plus 1 squared is the same thing as u plus 1 times u plus 1. You kind of FOIL that out, you're going to get the same thing here. So Jew, bro, is that really your name? Legend JP Stan, that's probably a little better. We are going to do a partial fraction problem after this because this doesn't really require partial fractions because we were able to factor this pretty easily because now all we're going to do is u sub or another u sub, wouldn't you think? Because now we can just say, okay, well, you know what? We already used u, so we're going to say w equals u plus 1. So then dw is equal to just du. And I realized my integral did not have a du. How dare I? And then so now we can rewrite this. We have integral of 1 over w squared times dw. And we can rewrite this just because the 1 over w squared on the bottom or because the w squared is on the bottom, we're going to do integral of w to the negative 2 dw. And then we're just going to go ahead and use power rule. So this is going to be negative 1 over w plus c. But then don't forget that w was equal to the u plus 1. So I'm going to put this on top because I know a lot of people talk about how sometimes the comments could kind of block the answer. So far this is negative 1 over u plus 1 plus c, but then u was equal to tangent. So really our answer is negative 1 over tan x plus 1 plus c. And that is our solution. Okay, so let's go ahead and do one with partial fractions because that will get some people going. We'll do one that's kind of easy. Actually, no, I do have one on here. What do we think? Yeah, let's go ahead and do this one. This is going to be a partial fraction one. Let me just go ahead and rewrite it. And again, anyone who's joining here, just remember that we do this every Tuesday around this time. And if you ever want to watch the replay, I do record these and I post them on my YouTube channel. So you can always watch them there. Aha, look at that. Integral of x cubed over x squared plus 1 squared dx. Thank you. Yes, hold the live stream and click the clear mode if you want the comments to disappear. All right, let's continue on here. What should we do? It's definitely going to be, is this going to be a u sub, or should we just continue with partial fractions, or do we have some other ideas on how to solve this? You know, I'm thinking that, can we divide the equation? The thing about that is the degree of the top has to be equal to or larger than the bottom. Then we can go ahead and divide. Now, you might think, well, on the bottom, it's x squared plus 1, but it's still squared on top. Or it's still squared again because it's x squared plus 1 squared. So technically, it's a 4th degree. So let's go ahead and actually use partial fractions on here. This is going to become, this integral x cubed over x squared plus 1 squared dx is going to become a over x squared plus 1 plus b over x squared plus 1 squared. Now, I made a mistake on purpose. Can anyone catch that? What did I do incorrect? So, Peter, if you try u substitution or making the bottom u, you wouldn't be able to cancel stuff out. Yes, someone said, I am, what is this? I am who I think I am not. It's weird. Live should really just give you the username. But yes, Connor, Everyone's saying it should be ax plus b. Absolutely. Absolutely. It should be ax plus b on top. So it should be a linear factor because every time your denominator is quadratic, for example, in this case, your top or your numerator has to be a linear factor. So check this out. For the x squared plus 1 for the first one, I need to rewrite it as ax plus b, and I need to do the same thing for the other. Got to be very careful here. And so now we can go ahead and use our partial fractions to solve for the values of a, b, c, and d. So what this is just going to become is ax plus b times x squared plus 1 plus cx plus d is equal to x cubed. That's really nice. And I don't think we can use the cover-up method here. I'm actually just going to have to FOIL out the a and the b and all that so that I can combine some like terms. So what I'm going to have is ax cubed plus ax plus bx squared plus b plus cx plus d is equal to x cubed. Let me combine all the like terms. The a, x cubed is by itself. I can combine the a and the c, because those have an x in common. So I have a plus c times x. And then I'm going to combine, let me actually do the x squared first. I'm sorry. So I have b x squared. And then I have the a plus c x. And then the last one that I'm going to combine is just the constants. B plus D is equal to x cubed. And now what are we left with? Well, if we try to make this equal to the right side is just x cubed. So that means that a, since that's the only coefficient in front of the x cubed, that means that a is equal to 1. That's really nice. Let's go to the x squared. Well, on the right side, there's no x squared whatsoever. So that tells us b is equal to 0. That's really nice. Now we start off with the coefficient in front of x, a plus c. If we compare it to the right side, there's no coefficient for x. So that means that a plus c is equal to 0. We already know that a is equal to 1. So we have 1 plus c is equal to 0, meaning that c is equal to -1. And then for the constant, there's no constant on the right side. So that means that b plus d is equal to 0. We already know that b is 0. So that means that d is going to be 0. And then so now the integral that we have, x cubed over x squared plus 1 squared is equal to the integral of that first one, ax plus b. Our a was 1, so we have x plus b, which is 0, so it's just over x squared plus 1, plus, and then on the other side, we have -1x, there's no d, so just over x squared plus 1 squared dx. All right, let me go ahead and create some space on the blackboard. If there's anyone new on here, we'll love to know any fun fact. What are we doing today? I know it's Tuesday, possibly some homework. For some people, it might be Wednesday, if I got my time zones correct. And what was Zaza? All right, let's go ahead and start combining this or starting to simplify this. Let's talk about the first integral. So we're going to work on the one that I'm highlighting here in red. How should I solve this? I don't know if you, Pebbles, you said you did it with USub. Try it again. I don't know if you can do USub. But the way we're going to solve this, we're going to go ahead and use U substitution for that first one. So if I'm just going to kind of cut some corners here, but basically the bottom is going to be x squared plus 1. So what this is going to become is 1/2 natural log of x squared plus 1. Think about how I did that. I was already thinking of the derivative for the natural log of x squared plus 1. And I just put a 1/2 in the front because when I take the derivative of the inside, I get 2x, so it cancels out. And then for the other one, this is actually going to become, I'm still using U substitution for this one. My U is that bottom value. And what this is going to become is positive 1/2. And then on the bottom, it's x squared plus 1 to the power of 1. Think about how I did that. Again, if you replay this on my YouTube channel, hopefully you can kind of work it out or take a picture of this, take a screenshot, and try to see how I got that answer. All right, cool. Calc 4. What would Calc 4 be? So there's Calc 3 and multivariable. What will Calc 4 be? What are you covering in that class? Anyway, I'm going to go ahead and erase this, but I'm curious what you're covering in Calc 4. All right, here we got another one. Let's do integral of e to the root sine x all over secant x root sine x dx. Oh, how are we going to solve this one? Oh, differential equations, linear algebra. Got it. Yeah. Yeah, interesting that they call it Calc 4. I mean, I think that's nice. That's good. Oh, I see. Diff equations. Yeah. Most people will just like take the differential equations class. They should call it Calc 4. It's kind of nice. It's like leveling up, you know? Looking at this integral, we'll love to hear your suggestions. What should we do? Should we use, I don't know, integration by parts, USub, the Feynman technique? What do you think? Let's start off with a nice clue. Let's use USub. So we're going to make u equal to the root sine of x. Ah, there we go. Our program said u sub. Okay. So du is equal to 1 over 2 root sine x dx. And if I multiply the 2 root sine x to the other side, I'm going to have 2 root sine x du is equal to dx. So now let's go ahead and just rewrite this. So I have e to the u over secant x root sine x times, and now we're going to go ahead and substitute that entire value for our dx. And that's what I'm left with. And what's really nice is that the sines of, or the root sine x cancels out. That's exactly what we wanted. So I'm going to do two things. I'm going to move the 2 out on the, that's exactly what we wanted. So I'm going to do two things. I'm going to move the 2 out on the front, and I'm going to rewrite that secant as 1 over cosine, and it's going to go on top. So this is what's going to happen. I'm going to have 2 integral of cosine x e to the u du. Again, what I did is we rewrote that secant x as 1 over cosine and then put it on top. Oh, that's a good, so Samuel, I didn't make, I just made u equal to root sine of x. Had you made u equal to the e root sine of x, then yeah, that would have worked out. Which I think, would that have been better to do? It's 2 sine x. None. So Sam, here's the thing. I didn't. Everyone's so let me show you what I did. I actually just made u equal to root. I'm over here thinking like, man, you guys don't know what you're talking about. I know exactly what I did. Yes, you're absolutely right. Let me go ahead and do that. Let me just rewrite this. Let's go back. Yo, that would have been costly. So going back to our du. Oh my goodness, I was just kind of running with the flow there. I completely forgot to multiply everything by cosine. So there should be a cosine on top here because I need to apply the chain rule. Thank you, everyone. Yeah, so now we have the dx. And then now we're going to go ahead and do 2 root sine x over cosine x dx. And so now here's what's going to happen. This is going to be much easier. So now we have integral of e to the u over, and then I'm going to rewrite that secant as 1 over cosine times root sine of x. But then we have our du, whoops. Don't forget that our dx was equal to this entire value that I'm circling in green here. So now what we have is we have 2 root sine x over cosine x du. And yes, you're absolutely right. Now what's going to happen is a lot of things are going to cancel out. That root sine x and the cosine x cancels out. So all I'm going to be left with is put the 2 on the other side. Thank you, everyone. It was like, Samuel, you guys were adamant. Like, no, stop right there. There's something going on, and you're absolutely right. So now I'm left with just this, 2 integral e to the u. And now all we have to do is just integrate e to the u, and that's just 2 natural log of u plus c. That's 100% correct. I made no mistakes on that one. Ian, just follow along. It's all part of having fun with this. By the way, I'm going to change this before the comments go off, before Samuel and who was it, Pilgrim. A lot of people were just going off, but this was incorrect. I was just trying to mess with you guys. The integral of e to the u is just e to the u. So we have 2 e to the u plus c, and now we just plug in our value of u back into our answer. So 2 e to the root sine x plus c is our answer. Yeah, so typically integration be it's kind of like, I try to bring a couple problems here. So if you think of the integration techniques, it's like u sub, integration by parts, long division, right, or partial fraction decomposition. So it's all about like this different situations that you could be in. But let me show you one that I think is actually really fun. Okay, so Now that I do that, I see a few new people joining in. I would love to hear where y'all are tuning in from. We had Utah, we had Scotland, we had England or London, I believe. We had someone from Malaysia. What else do we have? I refreshed the chat when my my computer was freezing there. Florida, that's awesome. Okay, so now we're gonna do a different problem here. So let's go ahead and do 6x plus, let's just do 31 over 3x squared minus 4x plus 11. Seattle, bruh. That's awesome. Ohio, Samuel. I see. Houston, Russia, Illinois. Oh my gosh, Samuel. I hope you're doing well in Ohio. I know there's a lot of things going on out there, but you know, stay strong, brother. Setting course collision. Oh my gosh, I'm too dumb to recognize that flag. That is. You're just gonna have to tell me, or someone's commenting on there. Bro, you gotta just tell me. Anyway, coming to this one. This specifically, this one is dedicated to our Seattle friend, bruh, who wanted some integration technique examples. So check this one out. This is one that I really enjoy because you kind of have to change it up a little bit. Series, maybe on a Thursday. That's technically what we like to do. Oh, UAE, nice. Okay. Okay, so back to this problem. This is something that I really like to do because it's going to be a U sub, but think about what that U sub is going to be. So you can kind of play around with it first so you could, you know, kind of once you recognize it, you were going to change some stuff. So we're going to make our U our bottom, but I want you to think about what's going to happen. So if we make U equal to 3x squared minus 4x plus 11, which is fine, our du is going to be 6x minus 4. But that's not what we have on top. We have a 6x, but we don't have the 31. Okay, so what we have to do is we have to kind of make sure we're going to manipulate the top before we even do use substitution. So look what I'm going to do. I'm going to rewrite my integral. So I have 6x. Whoops. I'm just going to write it in yellow. So I have 6x. And then I'm going to add that minus 4 because that's what I want, because I know that if I use substitution, I want to have that. We still have the plus 31, but because I introduced a negative 4, I'm going to go ahead and add a 4 to that. And now this is what I have, 3x squared minus 4x plus 11. Yes, you're right, Pebbles. I'm going to do that right now. You know what? I wasn't worried about that too much because formality, you're right. You're absolutely right. So that's why I changed it up, because now what's going to happen, this integral is going to turn into 6x minus 4 plus 35 over 3x squared minus 4x plus 11. This one's really cool because, again, we kind of did use substitution, but then we manipulated the numerator so that we can have this the u cancel out, or our du. We can have the 6x minus 4 for our du on the numerator. So now what we're going to do is we're going to split this up. We're going to do 6x minus 4 over 3x squared minus 4x plus 11 plus integral of 35. My writing was so bad there. 35 over 3x squared minus 4x plus 11. And both of these should have a dx. That's for Pebbles right there. Got to have that dx, right? We're like so conditioned to make sure that it's there. It's just like the plus c. If we don't write the plus c, game over. Okay, this is really nice. I know it looks a little messy, but the first integral, we're just going to do u substitution. We're not going to worry about that one too much. We're just going to solve it now because we kind of already know what that is from the very beginning. So the first integral is literally just going to be natural log of absolute value of 3x squared minus 4x plus 11. But then now we have to go ahead and start playing with that second integral. Ooh, hold on. I don't know what happened here. Let me just erase this real quick. Oh my goodness. What happened to my writing there? It's like Zoom just gave out. Okay, we had 35, 3x squared minus 4x plus 11. Okay, we have to do something about that second integral. Who can give me an idea? It's a tough one, but honestly, once you kind of manipulate it, or like you kind of recognize what you have to do, it's fun. It's all part of it. But now again, we need to integrate that second integral. Let me just rewrite it in case people don't see it. We need to somehow change this integral in some way. What do we think? We have a quadratic on the bottom. Irving, if you want to, yes, go to the link in my bio and go to the Discord and then post it on there. Go to my calculus and post it on there and I'll find it, or just post it in general. So someone said natural log. Partial fractions. Okay, but before we even do partial fractions, we're going to have to factor this out, right? Let me just see if I can even factor that out. I'm going to do that slip and slide method. So I'm going to take the 3 and multiply it to the 11. So I need to find two values that multiply to 33, add to negative 4. What is that? 3 and 11, and that's it. So it doesn't look like we can even factor that out. So Pebbles, what I did is, again, we saw that u was going to equal to 3x squared minus 4x plus 11. So we introduced the minus 4 on the top and then obviously added the 4 on the top as well. And now we were able to cut it apart, or we were able to cut into two different integrals. And then for this integral that I'm circling in blue, all we did was a u sub there. Okay, so partial fractions didn't seem like it worked because I can't factor out the bottom. Or at least I don't know how. So you know what I'm going to do? It's funny because this is one of my most hated methods, and it seems like we all hate it because we don't want to admit that we have to do completing the square. Trig identity. I think it's going to be a trig identity. Electrotropic. But it's going to be one that we recognize. Now check this out. Again, no one wanted to admit this, but we have to complete the square. This sucks. Okay, so we have natural log of 3x squared minus 4x plus 11 plus, and then here's what I'm going to have, 35. Let's factor out, oh, guys, I don't want to do this, but, I mean, we kind of have to, unfortunately. Let me factor out a 3 from the bottom. You're going to see why I'm doing this. It's going to get nasty, but it's going to be the only thing we can do. I'm going to have an x squared minus 4/3 x plus 11/3. Trust me. Trust me. I know what I'm doing. What happened to the 6x minus 4? It was here. I'll highlight it in blue or red so you can see it. And then it turned into this solution here. Yes, so factor out the 3, it's going to be an arctan. That's exactly what's going to happen. It's as nasty as it is. Again, no one wanted to admit this. Everyone loves completing the square until there's fractions involved. This is why I hate it so much, just because it's like, it's powerful, but such a waste of time sometimes, you know? Okay, so here we go. Now we have, let me just rewrite everything. Natural log of 3x squared minus 4x plus 11, and then plus 1/3. How about I bring the 35 outside too? So 35 over 3 over 1 over, and now we're going to go ahead and complete the square. X squared minus 4/3, and don't forget to complete the square. You have to divide the 4/3 by 2, so that's 2/3, and then square it, so that's 4/9. So what we have is minus 4/3 x plus 4/9, and then plus 11/3, but because you introduced the 4/9, you need to subtract the 4/9. This is why we all hate completing the square, because now, when I continue to rewrite this, I have plus 35 over 3, integral of 1 over, and then now, this is just going to become x minus 2/3 squared, plus, I just got to get common denominators for those last two fractions, and that's going to be 35 minus 4, so it's going to be 31 over 9. That's okay. You know, it's a little messy. But isn't that nice? Look at this. This integral here is a very common arctan, where our u is equal to x minus 2/3, and our a is the square root of 31 over 3. I just took the square root of 31 over 9. And as always, I'm going to have to go ahead and just make this smaller. And we're going to finish this off, guys. This is natural log of 3x squared minus 4x plus 11 plus 3/5, or 35 over 3, I'm sorry, times 1 over root 31 over 3 arctan of x minus 2/3 all over root 31 over 3 plus c. And we can, I mean, I don't want to rewrite this, but you can simplify that 35 over 3 times root 30 times 1 over root 31 over 3. The 3's cancel out, and you can just continue with that. But I'm just going to leave it like this for now. Oh, this is fun. This was kind of like a nice different. So when you see this, hopefully you see it in the future. You kind of have to think about, like, okay, if I make this my u, what would happen? So we had to manipulate that. Awesome. Okay. I have another problem that we can do. Oh, this one's interesting. This one might require some partial fractions. Let's see. How much time do we got? Well, yeah, we're in here. Maybe we can throw in another problem and then call it today. But as always, guys, as I write this, don't forget that I'm here every Tuesday around this time. And then Thursdays, we do math survival skills. So we'll do, something very specific to kind of continue increasing or strengthening those math skills. And then Fridays are off trails. Here we go. 4x cubed plus, nope, let me change it to minus x plus 1 over x cubed plus 1. And then this is for Pebble, the dx. Got to write that down. Was it 20? Oh, because it was 33 minus 4. You're absolutely right. Thank you. That's what happens when I'm thinking of the next step. I'm making sure everything's working here, reading comments, and I made that one mistake. So if you're watching this on the replay on YouTube, keep in mind that it shouldn't have been 31 over 9. It should have been 29 over 9. It's a simple arithmetic. So bad. Okay, so here we go. Any suggestions? What should we do with this? What can we do? Someone said you can divide the equation out first. That's exactly what we're going to do. Yes, divide. That's exactly what we're going to do. Okay, so let me go ahead and set this up. This has to be a long division problem, unfortunately. It can't be a synthetic division, so we are just going to have to show all the work, and then I'll make it small and then just put it off to the side. So we're dividing this whole thing. 4x cubed, and then look, plus 0x squared minus x plus 1. Always have to account for the missing terms there. So I have x cubed plus 1 on the outside. It's definitely going to be a soap. Hey, that's awesome. Integral tests. Yes, integral techniques are fun. I think it puts everything to the test. I mean, and you can make such little mistakes that can be very costly. It can go from like your arithmetic. Can you do your fractions? Can you divide things in this case? Can you recognize different scenarios? So, it's like doing some, I don't know, karate or something, whatever. Anyway, long division. Let's go ahead and do this. Now we got to ask ourselves, what do we multiply to the x cubed to get 4x cubed? That's going to be a 4. So that's going to be 4x cubed plus 4. Oh, this is going to be interesting. Okay. And don't forget, we have to subtract this. This is like basic arithmetic when we were like in 4th or 5th or 6th grade. The x cubes cancel out. I am just left with negative x and then minus 3. Okay. Oh, I don't like that. I don't like that one bit at all. Okay. If I made a mistake here, I don't like the way this looks, but it looks like that's it. So this is my integral of 4, and then my remainder, I'm just going to put a plus and then negative x minus 3 over and then x cubed plus 1 dx. area under the curve. Nice. So this is basically just integrals, and make sure you always are subtracting the top function minus the bottom function. If we need to find the parameters, check what they're equal to each other and all that. Okay. If this long division does not look correct, let me know. I don't like the way this came out, but I think that's the answer. Yeah, if no one's saying that I made a mistake, I'm going to continue. Looking at Samuel, I'm looking at ZXTLMM. You said I had made a mistake. You caught it the first time, and then there was Pebble. So if anyone sees it, please, if you feel like I made a mistake in the long division, let me know. Anyway, well, we're going to continue. So now we're going to integrate the 4. That's just x, or 4x. Plus, and then we have the integral of this, negative x minus 3 over x cubed plus 1 dx. I don't like this at all. But does anyone have suggestions on how we can go ahead and integrate that? I feel like it got worse. Let me go ahead and make this smaller so if people can't get rid of the comments, they can actually see what I have on top here. We are trying to integrate that right there. Integral of negative x minus 3 over x cubed plus 1. Okay. Yeah, rewrite it as 2 fractions. Abby said u sub. Think about that. Just think about if we use u sub. U will equal x cubed plus 1. Du will equal 3x squared dx. And just think about, would that even cancel the numerator? It just won't. But it's always good that you think about that method, but you always have to try it out. And in this case, I don't think it's going to work just yet. So we are going to have to factor this out and use partial fractions. Someone had guessed that it was going to be this SOAP thing. Who recognizes this the x cubed plus 3, or the x cubed plus 1, I'm sorry, that sum of cubes? Who recognizes that as SOAP? That's how I remember it. There you go. Okay, I just rewrote the bottom there. That is just a sum of cubes. SOAP, same, all opposite, always positive. So that's just a way to remember the signs for when you factor this out. So same, when I circle the plus there, it's just the same sign as the original. So if x cubed plus 1 was, because it's a sum, it's going to be a plus. And then the opposite, the O, so the opposite sign, and then the other one is always positive, so it's always going to be a plus. That's how people memorize it. It's kind of like when people use tabular method, I like to call it tic-tac-toe. Integration by parts, I like to call it ultraviolet voodoo. Everyone just has different ways of remembering this. Okay, so I think now, unfortunately, partial fractions. Let's go ahead and do that. 4x plus this integral, or maybe we should just talk about that integral. Let's not worry about the 4x right now. Let's just rewrite that. Whoops. I am trying to get the eraser on here. Okay. This integral, unfortunately, looks like this. A over x plus 1 plus bx plus c over x squared minus x plus 1. Oh. Don't like that at all. Because now what we have, if we continue with the partial fractions, we're going to have a, and then x squared minus x plus 1 plus x plus 1 bx plus c, and that whole thing is equal to negative x minus 3. Yikes. Okay. Whoops. I moved my whiteboard there, but let me just change it up. Okay, let's go ahead and continue. And guys, just so you know, this is unfortunately the last problem that we're doing for today, but please follow me here on TikTok, follow me on Instagram, join our Discord, follow me on YouTube. We're always doing math here. Oh, that's awesome. We just learned this yesterday. Okay, so let's continue. It looks like what I'm going to do, I don't even think we can use the cover-up method here. I mean, we can only use it, I guess, to get rid of the... I'm not going to do the cover-up method here just because it's not like linear factors. So what I'm going to do is I'm just going to distribute the A to everything, and then I'm going to FOIL the other one. Sometimes the cover method can be too much work. So I have ax squared minus ax plus a plus bx squared plus cx plus bx plus c. And that's going to equal to negative x minus 3. So let's combine the x squareds. I have a plus b is x squared. So the x squareds cancel out there. Plus, I have negative a plus b plus c. Those are my coefficients for the x. So I can kind of get rid of those. And then I have the last one's a plus c is equal to negative x minus 3. Yeah, I wanted to rewrite it, but I'm like, I'm just going to leave it there. You said rewrite the negative x minus 3. Oh, that's awesome. Yeah, you see me on shorts? That's cool. Yeah, typically the shorts are going to be just the same as here on TikTok, but obviously TikTok will have other type of videos. And then if you follow me on Instagram, there's always like practice problems that I don't normally post elsewhere. And then, of course, always join the Discord. I mean, you got to join that. It's where a bunch of math nerds are at. Okay. So let's go ahead and compare the coefficients. So there's no x squared on the right side, so that means that a plus b has to equal to 0. The coefficient for all the x's is negative 1, so that means that negative a plus b plus c is equal to negative 1. And then that means that the constant a plus c has to equal to negative 3. Okay, so we kind of have to just mess around with this. But it's okay. We're just going to use a system. Okay, this is the way it's going to work. For that first equation, we're just going to say that since a plus b is equal to 0, b is equal to negative a. All I did was subtract the a to the other side. And then now we're going to use that to substitute this for the bottom. So now this second equation is going to become negative a. And then instead of the b, I'm going to have minus a plus c is equal to negative 1. And that simplifies to negative 2a plus c is equal to negative 1. And that's really cool because we can compare it to the third equation. So we have negative 2a plus c is equal to negative 1. A plus c is equal to negative 3. Let's just go ahead and subtract these. And that tells us that negative 3a is equal to 2, I believe. I just subtracted these. I'm just double checking my work. Negative 1 plus 3 is 2. Perfect. And then you get an ugly a is equal to negative 2/3. Okay, let me go ahead and make this smaller. Arm partial fractions just fun. So fun, right? Okay, so we said that a was equal to negative 2/3. That means that b is just the opposite of that, so that's 2/3. And that tells me that c, I can use the third equation. So because a plus c was equal to negative 3, so then negative 2/3 plus c is equal to negative 3. So then c is equal to, that is going to be negative 7/3. Don't blame me. I use a calculator for that. I didn't want to think about that in my head. Okay, so c is equal to negative 7/3. And I think we found all our values. So now we have, so far, we're going to have this integral. Let me just write it on the bottom, and then I'll make my stuff smaller. So 4x plus, and then now we're going to have integral of the a value, so negative 2/3 over x plus 1, plus our b plus c, so 2/3 x minus 7/3, all over x squared minus x plus 1 dx. Oh, no. I can kind of already see that there's going to be an issue with this integral on the bottom because we're going to have to rewrite it. But we are going to run out of time. So that's something that you guys can kind of do at the end. Okay. So we have 4x plus this first integral, or that the only integral that we have, the first one here, is minus 2/3 natural log of x plus 1. All I did was use u substitution there. And then now this is where I'm just going to leave it up to you guys. Think about how we're going to solve this. This is going to be negative 2/3 x minus 7/3 over x squared minus x plus 1. We're going to have to solve that one on our own. And I'm curious what your answer is. This is actually just like the other problem that we just did, where we have to manipulate the top and the bottom. Let me show you real quick. Okay? If I rewrite this, I'm going to pull out the 1/3 from the numerator. So that's going to be 1/3 integral of 2x minus 7 over x squared minus x plus 1 dx. And remember on the bottom, think about that. We're going to make that bottom our u, but our du is going to be quite different. Think about that, okay? If we make this our bottom, u is equal to x squared minus x plus 1, then our du is 2x minus 1. Well, we don't have that on top. So we're going to have to somehow manipulate the numerator. Let me just rewrite it and then a little more, and then again, you guys can finish this off on your own. But it's going to look like this. So I still have the 1/3. Integral of 2x. I'm going to introduce that minus 1 on there. I still have the minus 7, but because I introduced the minus 1, I have to introduce a plus 1 as well, because you still have to even out the numerator. It still has to be the same equation. And then now you're just going to have to separate this into two different integrals. It's definitely going to be a natural log pebbles. If you go to the link in my profile, there is going to be a Discord icon on there. It should work. The invite code should work. I think I have it so it never expires. But you could always go on there. If it doesn't, let me know somewhere in one of the videos in my TikTok, and then I will make sure that I update it if it doesn't work. Nicole, this is calculus. Okay, what do you think? Should we just finish this integral off together, or do you guys just want to do it on your own? Let me know in the comments what we think. Let me make this smaller. As you guys think about that, I'll just rewrite it. Okay, here we go. Dang, the work just keeps getting smaller and smaller. That's kind of cool. Abby says together, okay. All right. So let me just show you. I have 4x minus 2/3 natural log of x plus 1 plus 1/3. And then check this out. This becomes 2x minus 1 and then minus 6. That's what we're going to separate. Now we're going to separate this into two different integrals. It's going to look like this. Plus 1/3 integral of 2x minus 1 over x squared minus x plus 1 dx minus, and then I have 1/3, because that 1/3 still needs to carry over, 6 over x squared minus x plus 1 dx. And I think I need to make this a little smaller. It's actually not as bad as we think. Oh, here we go. Okay. We still have the two terms that were really relatively simple. This next integral, the first integral that we have to complete is this one here that I have in red. That's just a u sub. That's exactly what we wanted to do, because we make our u equal to that denominator. So that is just going to be 1/3 natural log of x squared minus x plus 1. And then that last integral, we can use u sub, so we're just going to have to complete the square for that. I don't think we can factor it out. So this is what it's going to become. Let me just go ahead and simplify this. This is going to become minus 1/3. I still have integral of 6. Actually, here's what I'm going to do. I'm going to actually bring the 6 on the outside so that I can have 6 over 3 on the outside, meaning 6 over 3 is just 2. And then I have integral of 1 over, and check this out. I'm going to complete the square. This is going to be x squared minus x plus 1/4 plus 1 minus 1/4 dx. Okay. Let me just rewrite this a little more. God, these are fun, aren't they? X squared minus x plus 1. And then so I have minus 2. If I rewrite this, this becomes x minus 1/2 squared plus 3/4. And what this is just that last integral is literally a very, not unique, a general arctan problem. So we have u is equal to x minus 1/2. Our a is equal to just the square root of 3 over 4. So this is root 3 over 2. And so now we're just going to finish this off. Let me just go ahead and make this a little smaller. And as I mentioned, this is our last problem. But if you want to see the beginning of this live, these are recorded and posted on YouTube for you to watch whenever you like. And again, if you feel like you caught a mistake, let me know in the comments. But please follow me here on TikTok, follow me on Instagram, follow me on YouTube, join the Discord. All right, let's go ahead and complete this. Now we have all this, minus x plus 1, and then I have, check this out, minus 2, and then times 1 over root 3 over 2 arctan of x minus 1/2 all over root 3 over 2, and then don't forget your plus c. Now, one thing that I'm going to do is I'm just going to simplify it one last time by combining that ugly like looking fraction that I have here in the 2 and the 1 over 3/2. So plus 1/3 natural log of x squared minus x plus 1, and then minus 4 over root 3 arctan of x minus 1/2 all over root 3 over 2 plus c. Whoo! Oh yeah, buddy. I'll tell you what. Pretty neat, huh? You take this in 12th grade. Yeah, I think this is typical. This problem is generally not like in a 12th grade problem or like an exam, but something that is taught as well. And I believe, I don't even know what the integral of this was. From the very beginning, I'll put the integral here in case you guys are just joining. This was the integral of 4x cubed minus x plus 1 all over x cubed plus 1. Oh boy. It's funny. I always write these down not knowing what the solution's going to be, and it ends up being this entire long problem. But pretty cool. Hey, Harry, what's going on? Yeah, the original. I wrote it on here in green. Hopefully you can see it there on the screen. That was the original integral, and that's what it becomes. So hopefully, again, this is all about just learning techniques. This isn't about, getting everything right. If you don't understand even 10% of this, that's okay, because you're just being exposed to this. And when you do see it in your class, or whenever you decide to kind of do these problems on your own, hopefully you can think of, these videos, and you can think back of the techniques that we did. That is great. Yes. I know there's a lot of POC kids that need help, so get after it. That's awesome. Good for you. All right. Anyway, so this was our last problem. I am going to be back on Thursday. We're going to do some math survival skills strengthening. And then on Friday, it's going to be off trail. So we'll see what we do then. But until next time, I hope you guys have a fantastic Tuesday, Wednesday, if it's Wednesday where you're at. And I'm going to see you guys real soon. Everyone take it easy, okay? Nice to see everyone. Bye now.